Now we have to check that this series is convergent or not. Whenever series is given and we have to check convergence of the series, then we can apply many tests, either ratio test, root test, and comparison test. But whenever factorial involved in the nth term of the series, then in most of the case ratio test will help you, because of some terms or factorial may cancel out, means factorial we can remove in ratio test. So this is helpful and we can easily find the limit. So according to ratio test, we will find limit of un upon un plus 1. If this is greater than, if this is greater than 1, series convergent. If less than or equal to 1, then we can't say. If less than 1, then it will divergent, and for equality it may or may not be convergent, means the test to fail. So in equality at 1, we need to further investigation for the convergence. So according to ratio test, un is n factorial upon 1, 3, 5 and so on up to 2n plus n minus 1, and this one should be divided by un plus 1, and that one is n factorial, sorry, n plus 1 factorial. So n plus 1 factorial can be written as n plus 1 into n factorial. This is very common, so I use this format. So n factorial divided by 1, 3, 5 and so on up to 2n minus 1, and last one will be 2n plus 1 after putting n equal to n plus 1, or you can say replacement. So this one cancel out by this one and this one is totally cancel out by this one. So un upon un plus 1 is equal to 2n plus 1 divided by 2n plus 1 divided by n plus 1. And whenever this is in linear format or in polynomial structure, so higher coefficient of the higher power exponent is 2 divided by 1, so this limit is equal to 2. Otherwise you can take n as a common, and n will cancel out, so 2 upon 1 you can find out in other way. So limit of this un upon un plus 1 is 2, which is greater than 1. So according to ratio test, it is convergent.